video, we shall be looking at another example on graphical solution of linear inequalities in two variables. The example given to us says, illustrate graphically the region in which the inequalities y minus 2x less than 4, 2y plus x greater than or equal to 5, and y plus 3x less than or equal to 6 are simultaneously true. Show on a graph the region that indicates that all of these inequalities are simultaneously true. Remember, we'll be shading all unwanted regions. We'll be shade unwanted regions. So why I want us to shade unwanted regions is because I want us to see clearly the region that satisfies this question. So let's go into the question. So the first inequality is y minus 2x less than 4. We are going to draw the boundary line for y minus 2x is equal to 4. Y minus 2x is equal to 4. So when x is 0, we have y minus 2 bracket 0 equal to 4. 2 times 0 is 0, so y becomes 4. So for this point, we have x as 0, comma y as 4. So next, when y is equal to 0, we have that 0 minus 2x is equal to 4. We are working with this. So minus 2x equal to 4, x becomes 4 divided by minus 2, x becomes minus 2. So for this point, we have minus 2, comma 0. So we'll draw our x and y axis. So let this be 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. 1, 2, 3, 4, 5, 6, 7, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. So when x is 0, y is 4. X is 0, y is 4. 1, 2, 3, 4. I'll mark this point. When x is minus 2, y is 0. Minus 1, minus 2. So I want to draw broken lines because the inequality here says less than. I want to draw broken lines that will pass through those 2 points. Having done that, we'll conduct our test. When x is 0 and y is 0, fix it in this original inequality. Fix it in this initial inequality here. You have 0 minus 2 bracket 0 less than 4. 2 times 0 is 0. 0 less than 4. 0 less than 4 talks about this region. So the unwanted region becomes your wanted region becomes the region above this line. Let's go to the next inequality. Next inequality says 2y plus x is greater than or equal to 5. So we're going to draw the boundary line for 2y plus x is equal to 5. So when x is 0, like we did before, when x is 0, 2y plus 0 equal to 5, 2y equals 5, y becomes 5/2. Then when y is 0, we have 2 brackets 0 plus x greater than or equal to equal to 5. 2 times 0 is 0, x becomes 5. For this point we have 0, 5/2. For this point we have 5, 0. So let's go to our graph and plot these points. So when x is 0, y is 5/2. 5/2 is 2.5. So we have, this is 1, this is 2, half will be somewhere here. Then here we have when x is 5, y is 0. 1, 2, 3, 4, 5. So we're going to draw a straight line, thick continuous line, because we have greater than or equal to. So let's conduct our test by making y 0 and making x 0. We have 2 brackets 0 plus 0 greater than or equal to 5. This is 0. 2 times 0 is 0. 0 plus 0. 0 is greater than or equal to 5. Is 0 greater than or equal to 5? No. The region that talks about greater than or equal to 5 is this region. So is 0 greater than or equal to 5? No. So we're going to shade that region. That's we're going to shade the region that contains the origin. So we have this. If you like. So let's go to the next inequality that talks about y plus 3x is less than or equal to 6. So we're going to draw the boundary line for y plus 3x is equal to 6. And then we'll assume that x is 0, and we'll solve y plus 3 bracket 0 is equal to 6. 3 times 0 is 0, so y becomes 6. So for this point we have 0, 6, and then for the next step, when y is equal to 0, we have 0 plus 3 x is equal to 6, x becomes 6 over 3, 3 here, x becomes 2. So for this point we have 2 comma 0. So let's go back to our graph and then plot these points. When x is 0, y is 6. 1, 2, 3, 4, 5, 6. When x is 2, y is 0. 1, 2. So we're going to draw eight continuous lines that will pass through these 2 points. I'll pass through these 2 points. I'll pass through these 2 points. 0 is less than or equal to 6 of 0 is less than or equal to 6. So in that case, the region containing the origin is required. So we have that after conducting that test, we have that 0 is less than or equal to 6. So the region containing the origin is true, is correct. So we're going to shade the other side of the line, which is the unwanted region. So let's shade this way, shade this way, shade this way, shade this way, shade this way. So R is the region that shows where all 3 inequalities are simultaneously true.